An exponential function is a function of the form f of x is equal to a to the power x, where the variable is in the power. So if you find 2 to the power x, that's an exponential. 7 to the power x, that's an exponential. E to the power x, that's an exponential. And so I want to take it something that you already know. First, we do the sketch. Sketch y is equal to 2 to the power x. So we do this, and I want to do it in such a manner that we recall what we used to do at high school. Yeah. So remember at high school, if you are taught to sketch something, there was always need for a table. So in this case, we'll pick the x values. Let's pick x values. Let's pick -1, 0, and +1 as our x values. So in our table, we need to solve for the y values like that. So let's see. When x is -1, what will be y? Y is 2 to the power -1. You know, when the power is negative, it's the same as having the whole thing in the denominator with the positive power now. And this is just 1/2. So we have 1/2 here. And then, again, when x is 0, we'll have 2 to the power 0. Any number raised to power 0, we get 1. So we have the 1. And again, 2 to the power 1. So this will give us 2. So we have a 2 there. So now we can have our sketch. How many x values do we have? We have 3, -1, 0, +1. At -1, we got half. Somewhere here. At 0, we got 1. And at 1, we got 2. Somewhere there. So now, you know, whenever you are sketching, we also try to see if it's possible to get the x-intercept. So even here, we'll be doing the same thing. So we get 2 to the power x and try to equate it to 0. Now, there will be no value of x that when you put there the power of 2, it will give us 0. Such that even 0 itself as a power, it gives us 1, which is non-zero. So we won't have a 0 for any power of x, meaning that we don't have the x-intercept. And so if you don't have the x-intercept, then the y-axis and the x-axis is going to act like, it's going to act as an asymptote. Since you're coming from rational functions, now we know the asymptote. So this is the asymptote because it's a non-case. And again, it makes sense to call it an asymptote because there is no value of x that you put here that will make this thing negative. Because as you can see, when we used x, which is -1, it gave us +1/2. So there's no any slight hope for a negative as the output. So it means that this will be like an asymptote, line out of the touch. And then we have our sketch that type. Now this is a function y is equal to 2 to the power x. Okay, so you'd want to make a quick comparison as to what happens if the power was negative. So if the power was negative, using the same numbers, we would have had a y here. That int is for the negative power. So when you do y is equal to 2 to the power negative for the function, and then when we are dealing with -1, This then becomes 2 to the power positive 1, which is just a 2. So we have gotten a 2 here. So we're extending our table a bit so that if we have 2 to the power negative 0, it's still 2 to the power 0, which is 1. So 1 comes back. Guess what happens to the other one? Y is equal to 2 to the power negative for the function. Then we are bringing 1. Now we say this is the same as 1 over 2 to the power 1. So we get 1 over 2. So this now becomes 1 over 2 here. So if we go back the same sketch, against negative 1, now we got 2. So we'll have a 2 there. And against 0, we still got a 1. Okay, there. And against 1, what do we get? We get a half here. Okay. So we do the same thing. Our sketch comes from there. Like this. So this one is y is equal to 2 to the power negative x. So you guys who've done graphs, we did y is equal to x. You saw that these had families. This way, this way, this way, and the other way. So even these graphs of exponential, they also have families. They are found in families. And they are affected the same way when we add something, there was an effect. Even here, there will be effect, but the shape won't change. So we have sketched two functions on the same plane. Okay. So now, if I want, I can check what happens if we have y is equal to negative 2 to the power x. The obvious thing is that, we are just doing the negative of the function that we already used, the first piece. So it means that all the values will just become negative, negative, negative. So I'll make the table here again. This is x. So I have negative 1, 0, 1. And then this is y. So for negative, we got half, but now it has to be negative half. And then we got 1, it has to be negative 1. We got 2, it has to be negative 2. So when you come to sketch, you will now include negative half, negative 1, and negative 2. And so against negative 1, you get negative half. And against 0, you get negative 1. Against 1, you get negative 2. So we'll have another curve coming this way. And this curve is y is equal to negative 2 to the power x. So that obviously, if now we are to use, we'll have another curve coming this direction. And this curve is going to be y is equal to minus 2 to the power minus x. Now, whatever we do to 2 happens to any constant. It happens to any constant. Even the unknowns, for long as it's not 0. Okay, so this would remain the same behavior, even if we had to bring, let's say, e to the power x. E to the power x will maintain this value 1. But the other values like half and 2 won't be maintained, but the shape remains the same. Okay. So let me pick a bit of some questions here so that when we now start shifting these. Any questions? Okay. No question for now. So we can move. Let's do shifts. So let's do sketching. We want to sketch 1, f of x is equal to 3 minus 2 to the power x. Yeah, and 2, f of x is equal to e to the power negative x plus 4. So let's see what happens here. So for the first one, we can sketch the first one without using the table. So we know that this guy is a graph that comes which direction? That comes in this direction, where it passes through -1. Okay, but now we are adding a 3 to each point, and this is the asymptote. The asymptote is is y equal to 0. Now we're going to add the 3 to every point that we have here, including the asymptote. So it means that our graph is now going to have the asymptote 3 here. So the asymptote 3, and then, okay, there's a question.
Yes, sir. My network was bad, so I didn't hear your statement. Can you kindly repeat what you just said?
Okay, so when you have such a graph, we no longer need tables because we already understand the nature of graphs, like the nature of the graph of 2 to the power x. So we already know it. Okay. So then what do we do if we already know that nature? What we do is we find an easy way of doing things. We would put the graph of 2 to the power x that we know, which is here, and then understand that it has an asymptote at y is equal to 0, the x-axis. And we are here to add the 3 to every point, including the asymptote line. So instead of having it 0, you add 0 plus 3. You get 3 as the new asymptote. 1. 2, you have, instead of having -1, you're going to have -1 plus 3, which is +2. And then now you will have your sketch coming to cross at 2, and it goes down like that. So we are now supposed to find this intercept. But for now, we won't find it. I'll hang it a bit, then we'll come and do it later. Is that fine? So all I need to do is to master these. This is 2 to the power, this is -2 to the power x. So if they add a thing like 3, I'm just adding a 3 to every point that I have on my sketch. And how many points are important? Only the asymptote and the y-intercept. That's all. The other points are invisible. There are so many of them, so I cannot start saying, oh, this was 4, this was 7. No. At least the one that touches the y is my interest. The second one. Hello.
So I'm kindly asking how you came up with the graph. My network was bad, so I didn't get anything.
Okay, so let's go back to the graph. So in the previous page, what did we do? We found the graphs of 2 to the power x, of 2 to the power -x, of -2 to the power x, and the graph of -2 to the power -x. Now, this graph here It's the graph of minus 2 to the power x. This one. So what happens is this. I want to sketch the function 3 minus 2 to the power x. I want to sketch this function. So how do I sketch this function? I already know the graph of this one. And I know it does not change. So I get the graph of this guy, which is down here. I'm interested in only one point when x is 0. Just for this function, I will get the negative 1. So I have the graph. Then now this function f is saying to every graph, to every point that you have on your graph, can you add the 3? There's the 3 which is added here. This is the plus 3. So we'll start with the asymptote. The asymptote was the line y is equal to 0, which is the x-axis. So we add 0 plus 3. It moves to 3. 1. The second thing is the y-intercept. From being negative 1, you add negative 1 plus 3, it moves to 2. And then now you can go.
So how did we find the negative 1?
Negative 1 here. So when you substitute 0 where it's x, we say we'll have y is equal to minus 2 to the power 0. But what do we know about 2 to the power 0? 2 to the power 0 is 1. Because the minus is not powered. The power is only for 2. So that's how we get the minus 1. So this minus 1 has helped us to sketch the graph because this is the intercept we have here. So here we haven't solved for it. We have just used it as a point that we know that this guy is going to cross the y-axis.
Oh, all right, thank you.
And then, let me bring another one. The second one. The second one, again, I start with putting the graph. And I want to sketch this one. E to the power minus x. Well, I don't know what E is, but I know it's a constant. So what do? I go back and check. When the power is negative, I have E to the power negative x. Okay, so I'll compare it to this one. Okay, this is. So when we go back, we're going to just draw a line like this, representing the graph of E to the power x. So it will be a line like this, crossing at 1, and this is the intercept. I mean the asymptote. Now we are adding 4. So to every point, we should add 4, including which point? Including the asymptote. So our new asymptote is going to be y is equal to 4. This is our new asymptote. Okay, let me take it to 5. Okay. We're going to here. 4. And then I add. I'm now looking for this. So add 1 plus 4, I'll get 5. And then everything else comes back. So we'll have the space in this 5. The only thing we've tempered with is the asymptote. We added a 4 to 0, it became 4. The intercept, we added a 4, it became 5. Because it was initially 1. Okay? Well, suppose you have forgotten about these. You don't know the family shape. How can we survive? So let's go back and check. So if I have f of x is equal to 2 to the power x plus 3. And I've forgotten about the 5 minutes. I don't know how 2 to the power x looks like. I don't know that graph. Okay. And I've been told to show all the way to. So what I'll do is I'll pick some numbers. So let me pick the smallest number. I'll pick -1. I'll pick 0. I'll pick 1 as my x values. Then I'll have my f of x here. So
Can you just move to the previous page just a bit? All right, thank you.
okay, so what do? We say, okay, where there's x, we put a 1, a -1. So we have 2 to the power -1 plus 3. That is 1/2 plus 3. To add here, you get 5/2. So we have 5/2. And then, where there's x, we put a 0. So we have 2 to the power 0 plus 3, which is 1 plus 3, which is 4. So we have a 4 here. And then you put a 1. So we have 2 to the power 1 plus 3 times 5. And then you put the graph. So when x is -1, 0 must be 1. Okay. So we have, so the only thing that I should keep in mind is that even as I do this number that is always added is the asymptote. So I will have a 3 as the asymptote. And then when x is 0, I'll get a 4. So I've reduced my interest to only, so because I also want to check, is it going up from left or going up from right? Okay, so I can use now my values. When I have -1, I got 5/2. So 5/2 is a 3 point something. It's somewhere here. So the value there. And then that one, then 1 we got 5. Oh, up there. So it just gives me, so oh, your graph is going to be going like this. Okay. So it's going to be like that. So all I need to know is that the added number, this number, is always there. They are simple. And if that number, and then if you remember that number, they are simple, it becomes very easy because now, what is x, you put 0, you get the y-intercept. Yeah. So let me introduce you a bit to how exponentials relate with logarithms. So that we now start using the relationship because we are limited. We want to solve for the x-intercept when it's there. Now you need to move from exponential to logs at some point. So now, If I have y is equal to 2 to the power x, this relationship in logarithms is going to be the log of y is equal to let me not change direct. Let me write it in relation with what I want to expose. So this is going to be written in logarithms as x equal to the log y to the base 2. So if I'm in logarithms, this x is a subject of the formula here. But if I'm in exponentials, that subject is the power. The subject of the formula here in exponentials is the function inside y world. And then the base in exponentials is to the base in log. So this is the base. Even here, it's called the base. Okay, this is the power. Even here, it's called the power. And that y is our function. Even here, it is a function. If I want to use a direct relationship there. Okay, so forget about the naming. The question is, okay, so then if they ask me to graph x is equal to the log of 2 to the power y, and I've never known log, how then do I sketch it? Well, you would convert, don't sketch this one. Okay, as in direct, convert here. So you convert it. So you say, oh, for me to convert from x is equal to y base 2, I get 2 as the base. So I have 2 as the base, and the power will be x. I have the whole thing equal to y. This is now the point when you say, oh, I can then sketch. And the graph will come out this way, the graph will come out the same. But if you are told to sketch y is equal to the log base 2x, things have changed. You don't have to start looking for a y is equal to the power x. Convert what you are given to exponentials if exponentials are easy for you. So here you would say, oh, 2 to the power y is equal to x. So what is your variable now is y and not x. X is now your function. So in sketching, you will say, I have y now, it's given, and I'm looking for x. So if y is -1, then x will be half. If y is 0, then x will be 1. If y is 1, then x will be 2. And then the graph will come out. So you know again that, so here we have y, -1, 0, 1. And x, half, 1, 2. So we have a point there, we have a point there, and we have a point there. This time around, this power guy, this one, is the one that becomes the asymptote. So this is always the asymptote. Now, that variable is the one that gets the asymptote. And so the curve will be coming from down. Going this way. So this is the log. This is y is equal to log. Hello.
Wait, you said which power becomes the vertical asymptote?
If your power is y, then you have vertical asymptote. If your power is x, then you have horizontal asymptote. So if I'm dealing with pure exponentials, I have horizontal asymptote. If I'm dealing with logarithms, then I'll have vertical asymptote.
Oh, now get.
So what we have sketched here is y is equal to log x to the best. Meaning there are three more pieces to be sketched. The second one will be y is equal to negative log 2x. Then the third one will be y is equal to the log 2 to the power negative x.
Sir,
Hello.
what if they say sketch? They just said sketch 2 minus log x.
2 minus log x.
Yes.
Well, you still sketch, but you wait a minute. All the things that you'll be sketching is. So then we'll have a minus log 2 minus x. So we have these. So we have 4 of them as well here. 1, 2, 3, 4. So this is what we get there with us. How do you sketch? I want to sketch by first convert to exponential. And then second, use a table. Negative 1, 0, 1 for y. And find x. Then 3, sketch. And then submit. Okay? 1, 2, 3 graphs. Submit. Every time you learn, you must develop a tendency of submitting something. Even if there's no task, find a task in the lesson and submit. You know how we find tasks in the lesson and submit? You will try different, same concept, make your own question or look around, get a past paper, get a question there, answer and say, is this correct? You develop the habit of solving. Not to say, today I think I will task. I will just sleep. And let you make tips.
When are we submitting?
That's when you're done. Tomorrow we'll have a class again. I'm going for a physical class at 19. So tomorrow again, we'll be teaching. We'll have a class where now we'll talk about this same thing and then do questions like the one that was asked, where you are told sketch y is equal to 2 plus log x plus 2. And also to understand what lean means and things like the properties of logarithms. Just after the sketch, then you widen to the properties. So nice.
I'm saying is this is where he's introducing logs, then us already did them in the
So
Hello. Other question? Now the question here. What is it on? Please say it before I move to that.
Are you able to get me, sir?
Yes.
Yes, I was saying that I've seen that you've concluded with inequalities. But then we didn't do the ones involving the moduluses, like those to my bars
We haven't
that are
concluded.
found in modulus.
We didn't
Come
conclude.
again?
I haven't concluded invited.
Okay, all
I
right. Because
suspended
I
them
was
so that
trying.
you could introduce exponentials.
Okay. All right. Are we going to do them because they're all over in tutorial sheet 4 and I couldn't answer some questions?
We'll do them on Thursday.
All right, sir.
And then on Friday, I will be with those who are writing the test on Sunday. I will revise the test one which was written. Those writing will be there on Sunday. We'll be together on Friday. Now it's Saturday. I'll come with that. Don't mind.